Alrighty, folks. We're going to continue going through our analytical trig, and we're going to look at our next batch of identities. They're called the sum and difference identities, or the sum and difference formulas. Now, I'm not going to actually go through and prove these ones for you, although one of my favorite little websites I like to go to, themathpage.com, they do a real nice geometric proof. They do a real nice geometric proof of the sum and the cosine identities for this. So something to think about here. If you're a person that really likes seeing the proofs, you can find them. All right, it's a good little, and again, it's a very geometric one. It's really pretty slick how they do it. So, and what we're looking at here is basically how do we deal with determining the sum of two formulas. So for instance, say I asked where I wanted the sine of, and I'm not going to do this one, but say the sine of 17 pi over 12. Well, right now we only know the sum, all the trig angles for 16 angles, but there's a whole bunch of angles out there. So using those are identities that we do know, we can use them to find others that we don't know, like sine of 17 pi over 12. What these formulas basically say is try to figure out two angles that would add up to them. So biggest issue I would add to that is try to find two angles that both reduce and that add up to the given angle. So in other words, we want two angles that will reduce, because if they reduce and the denominator is 12, if they reduce, it will end up being some angles on our unit circle. For instance, 17 pi over 12, two angles that would reduce to give us that would be 8 pi over 12 and 9 pi over 12. We want angles that reduce, because 2 pi over 12 would be an angle on our unit circle that we do know, which is 2 pi over 3. And 9 pi over 12 would be an angle on our unit circle that we know, which is 3 pi over 4. And again, they don't have to be angles that would add. They could be angles that would subtract. So we could say something like 20 pi over 12, that would reduce. And 3 pi over 12, that would also reduce. So when we're using these sum and difference formulas, we're looking for angles that reduce. So what I'd recommend you do here, friends, is always keep these little formulas that we have at the forefront, because we're going to be diving in and out of these things as we go through here. So this would be 10 pi over, oops, we can go a little more than that. 20 pi over 12 would be 5 pi over 3, which is on our unit circle, minus pi over 4, which is on our unit circle. So sum and difference. I'm looking for either two angles on our unit circle that will add up to be this given angle, or that will subtract. What we can't do is pick an angle that might simplify with an angle that doesn't simplify. So for instance, I wouldn't come out here and say, oh, let's use 12 pi over 12, since that's going to be pi, that simplifies, and then add 5 pi over 12 to it. We wouldn't do that because 5 pi over 12, we don't know anything about that one. That one's not on our unit circle. So the key when we're dealing with what we're doing today is you have to pick two angles that will reduce. Two angles that reduce, 8 pi over 12, 9 pi over 12. They add up to 17 pi over 12, but they both reduce. 20 pi over 12 and 3 pi over 12. They subtract to be 17 pi over 12, but the key about that is they also reduce. They have to reduce as we go through. So we're just going to dive right on into this here and play around with this a little bit and see what we can deal with. So here we go. Find the exact value of cosine pi over 12. So let's do this first one together, just so we kind of have the gist of how this whole thing is going to work out here. So cosine of pi over 12. I'm looking for two angles that will reduce, that will either add or subtract to pi over 12. So when I'm thinking about it here, I'm thinking 4 minus 3 would work. I could have used 3 minus 2. So I'm going to use 4 pi over 12 minus 3 pi over 12. Just realize I didn't have to use these values. I could have also used any two values that will add or subtract to be, and that both reduce. So for instance, I could have used 3 pi over 12, which is pi over 4, and 2 pi over 12, which is pi over 6, just as easily as 4 pi over 12 and 3 pi over 12. I just went with the first one that kind of goes through my head. So if I'm looking at cosine of pi over 12, and it doesn't matter, by the way, which pairs you use, they'll always give you the same value. I'm going to use cosine of 4 pi over 12 minus, oops, I lied, minus 3 pi over 12. So I'm going to put them in here, because 4 pi over 12 minus 3 pi over 12 is 1 pi over 12. Now I can reduce them. So cosine of pi over 3 minus 3 pi over 12, that would be pi over 4. So these are the angles that I'm going to use for my formula. And what's that formula again? It would be right here. I'm using cosine and I'm subtracting. So I'm going to use this one. Now, you're going to hear us sing this song a lot in class here, but it's not really anything a little tricky. It's just kind of catchy. We're just going to sing the trig functions as we go through to help us remember them. So it's sine, cosine, cosine, sine, cosine, cosine, sine, sine. And then we get to tan, it'll be tan, tan, 1, tan, tan. And then we switch the signs. And the reason why we say switch the signs is, notice the signs are getting switched from what was happening the time before. So sine, cosine, cosine, sine, cosine, cosine, sine, sine, tan, tan, 1 tan, tan, switch the signs and do it again. So we'll sing it really fast. You all do it. You'll think I'm goofy and kind of dorky, but eventually you sing it with me. And it's sine, cosine, cosine, sine, cosine, cosine, sine, sine, tan, tan, 1 tan, tan, switch the signs and do it again. And we'll just sing that over and over again until we get stuck in our head here of what we're doing. So cosine is going to be cosine, cosine, sine, sine. Now, one of the things I want you to look at with sine is sine always has the same sign. Sine has the same sign. Cosine has the opposite sign. Sine is the same sign. That's kind of a tongue twister. Sine is the same sign. Cosine is always the opposite sign. So we go back to our problem that we're trying to deal with here. Whoop, right there. And notice how we got all this junk just kind of hanging out here. So we're going to do the cosine formula. So cosine is cosine, cosine, sine, sine. So we have cosine, so that means cosine of our first angle, cosine, cosine. So cosine, cosine, sine, sine, and then the sine of each angle. Sine of pi over 3, sine of pi over 4. And then you pick an, and then you look at your sign here. This is minus. Now on co, remember that it's always going to be the opposite sign. So that means this needs to be a minus. And now we're going to clean it up, friends. So cosine of pi over 3, well, that'd be 1/2 times cosine of pi over 4 is root 2 over 2. And, oh, that should have been a plus there. I said the opposite sign and I wrote the same sign. Plus sine of pi over 3 is root 3 over 2 times root 2 over 2. So when we put it together, we end up with root 2 over 4 plus root 6 over 4. So root 2 plus root 6 all over 4. All right. So sine, cosine, cosine, sine. That's sine. Then cosine, cosine, sine, sine. That's cosine. Tan, tan, 1 tan, tan. Switch the signs and do it again. All right, friends. So here you go. Here's yours. Why don't you go ahead and pause the video and see if you guys can do sine of negative 5 pi over 12. Go for it. All right, let's see how you guys did here. So negative 5 pi over 12. Well, if I'm looking at this one, friends, I'm going to think to myself, what if I did 4 pi minus 9 pi? And again, you could have picked different values. Doesn't matter. As long as they both reduce and they give me the sum or the difference I want, you will always end up getting the same value at no matter what angles you choose. All right, so I'm going to use this one, 4 pi and 9 pi. So negative 5 pi over 12. That's going to be the same thing as cosine as 4 pi over 12. Minus 9 pi over 12. So cosine of pi over 3 minus 3 pi over 4. Why did I keep putting cosine there, friends? I tell you what. The longer the year goes, the more mistakes I make. We're doing sine. Still, it doesn't change up what we're doing here. We're dealing just the angle part. So now we can go ahead and deal with the cosine part. So we have our sine. So sine is going to be sine, cosine, cosine, sine. So sine of our first angle, pi over 3. Cosine of the second angle, 3 pi over 4. And then we have cosine of the second angle, or cosine of the first angle, sine, cosine, and then cosine, sine. So again, I'm looking at this here. I see a subtraction here. Sine is always the same sign, so I'm going to use a minus in between. So sine of pi over 3, that would be root 3 over 2 times cosine of 3 pi over 4, that's negative root 2 over 2, minus cosine of pi over 3, so 1/2, times sine of 3 pi over 4, that's root 2 over 2. If you notice, I'm getting the same radicals that I got before. And in fact, you will always get the same radicals on these ones. Tangent will have different radicals, but sine and cosine will always have some combination of 2's and 6's underneath the radicals, and always have 4 in the denominator. All righty. Well, friends, why don't you let's go ahead and try cosine of 13 pi over 12 and see what you come up with. All right, well, let's see here. Cosine of 13 pi over 12. Maybe you did cosine of, 4 pi and 9 pi again. This is the one I'm going to do. 4 pi and 9 pi. But again, maybe you chose something different. Maybe you chose 3 pi and 10 pi. Maybe that's what you chose. I'm not going to do that one, but maybe you did. That's okay. Good for you. 10 pi and 3 pi. That would add up to 13, and they both reduce. Maybe you didn't do addition at all. Maybe you did subtraction. Maybe you did 15 and 2 and did subtraction with it. That's fine too. I mean, there's so many numbers, guys, that you can do and so many ways you can combine these. Doesn't matter. I'm just using the first one that kind of comes to my head. Doesn't matter how you do it, just as long as both fractions reduce and the numerators will add up to my other numerator. So cosine 4 pi over 12, that'd be pi over 3 again, plus 3 pi over 4. And no matter how you do it, you end up getting the same exact value. So cosine of pi over 3, that's going to be 1/2. 3 pi over 4, that'd be negative root 2 over 2. And then cosine of 3, or cosine, I guess I probably should have wrote it out first. Let's write it out first so you guys can see what we're doing here. I'm just doing it in my head and realize that's probably not the best teaching strategy there. Got to model it. Cosine, cosine, sine, sine. And then whatever the sign is that I'm using here, in this case I used a plus, therefore cosine I'm going to use the opposite. So I'm going to go ahead and subtract it. So cosine of pi over 3, well friends, that would be 1/2. Now we'll go ahead and evaluate it. We have a negative root 2 over 2 minus root 3 over 2 and root 2 over 2. So negative root 2 over 4 minus root 6 over 4. And that is negative root 2 minus root 6 all over 4. Well, how about we try a tangent? Why don't you guys go ahead and try this one. Tangent of 7 pi over 12. See where that takes you. All right, let's see how you did. Now, remember, a tangent is going to be tan of our first angle plus tan of the second angle. I could also be subtracting 2. And then 1 minus tan. So that's the tangent angle, 1. And if I decide to subtract an angle, this is me adding the angles. If I subtract the angles, then my plus and minus just flip-flop. So I see tan of 7 pi over 12. And I think to myself, that's probably going to, something comparable to that would be 3 pi over 12 and 4 pi over 12. So that's going to be what we're going to reduce. So the tangent of pi over 4 plus pi over 3. So sine, cosine, cosine, sine, that's sine. Cosine, cosine, sine, sine, that's cosine. Tan, tan, 1 tan, tan. All right, so tan, tan, and then 1 tan, tan. 1 tan, tan. So this right here, since I'm dealing with plus, then I'm going to put a plus in the numerator and a subtraction in the denominator. Because think about tangent, it's sine over cosine. Well, sine had the same sign, so the numerator gets the same sign. Cosine, which is in the denominator for tangent, gets the opposite sign. All right, now I've got to clean this up a little bit here. So tangent of pi over 4 is 1 plus tangent of pi over 3 is root 3. Then I have 1 minus 1 times root 3. And when I do this here, I'd have 1 plus root 3. There we go. And 1 minus root 3. Now, friends, if this were on an FRQ, that'd be a great answer. However, if it's on the multiple choice, then we're going to have to clean that up just a little bit by rationalizing the numerator and then doing a little bit of multiplication. So I'm going to go ahead and simplify it as much as I can to get rid of my denominator, or get rid of the radical of my denominator, I should say. So we have 1 plus 2 root 3 plus 3 all over 1 minus 3. So friends, that is 4 plus 2 root 3 divided by negative 2. So I have 4 divided by negative 2. And then I have 2 root 3 divided by negative 2. And friends, that's going to be equal to negative 2 minus the square root of 3. All right, well, let's keep going here. And now let's play with maybe just some sort of applications of this here. So here's what I want you guys to do for this one. I want you to draw the triangles that would represent these two angles. So go and pause the video and draw the triangles, and let's see if we can't do this one. All right, so if I'm dealing with U, I'm told that U is somewhere between 0 and pi over 2. So I know that it's somewhere between 0 and pi over 2. So that means all this is going to be gone. Not dealing with any of that. And they tell me that my angle, the sine of my angle, is 4 over 5. Using this same idea, friends, why don't you guys go ahead? Oh, I probably should finish this up here real quick. I need to figure out the x value to this problem. So if I want to find the x squared is, I'm going to use a little Pythagorean theorem here, friends, equals 5 squared. So I have x squared plus 16 equals 25. X squared equals 9. So x equals a plus or minus 3. And since I'm in quadrant 1 here, that's going to be a positive 3. So I'm going to put a positive 3 down here. Well, friends, using the same idea, see if you guys can go through and figure out what the triangle for V would look like now. All right, here we go. So I'm trying to deal with V now. It says I'm going to be from pi over 2 to pi. So that means all the rest of this is going to be gone. So we're not in quadrant 1 this time. No quadrant 1. No 3 or 4. So my triangle is going to be somewhere over here. And I have the adjacent is negative 12. My hypotenuse is 13. And friends, we're going to use the Pythagorean theorem to figure out what v is, or what y is. So y squared plus negative 12 squared equals 13 squared. So y squared plus 144 equals 169. Y squared is 25. And friends, y is going to be 5. So, using this idea now of what we have here for sine, so sine of u plus v, that's going to be the same thing as sine of cosine plus cosine sine. So using our triangles, so these angles that we were dealing with weren't on the unit circle, so we drew triangles for them. If they are on the unit circle, like the next two would be, then we'll just go and figure out those angles. So sine of u, well, that's 4 over 5. Cosine of v is negative 12 over 13. Plus cosine of u, which would be 3/5. And sine of v, which is going to be 5 over 13. So these two triangles, they weren't on the unit circle, so we had to actually draw them out. 65 and 15 over 65, which gives us negative 33 over 65. All right, friends, well, you see number 6 there. Those angles are on the unit circle, so go ahead and pause the video and see if you can figure out where those angles are, and then give that a try, see what you come up with. All right, so we're going to deal with u and we're going to deal with v. So u says I'm going to be somewhere between pi over 2 and pi. So that means I'm going to be over here. And I'm looking for an angle that is 1/2. So in between pi over 2 and pi, so that means I'm not going to be using any of this at all. So I'm between pi over 2 and pi. When is sine equal to 1/2? Friends, that would be at pi over 6. So that means u is going to be 5 pi over 6. And now we have our v. And notice for v is between pi and 3 pi over 2. So let's figure out where that would be. So pi and 3 pi over 2, we're going to get rid of all this over here. So we're between pi and 3 pi over 2. And we're dealing with some angle that's going to be cosine of negative 3 pi over 2. So that's down here. That would be 7 pi over 6. So that means my v value is 7 pi over 6. So they're asking for cosine of u minus v. Well, friends, what they're really asking for is the cosine of 5 pi over 6 minus 7 pi over 6. So cosine, cosine, sine, sine. Cosine. And I could actually have changed that to negative 2 pi over 6 to solve it, but I'm going to go ahead and just practice using my sum and difference formulas here. Sine, sine. And since I'm dealing with a subtraction, that means this is going to be a plus. So cosine of 5 pi over 6, that would be a negative root 3 over 2. Cosine of 7 pi over 6 would also be negative root 3 over 2. Plus sine of 5 pi over 6, that's going to be 1/2. And sine of negative pi over 6, that's going to be a negative 1/2. So I get 3/4 minus 1/4, which would be equal to 2/4, which is the same thing as 1/2. And like I said, friends, if I wanted to, I could have done this as well. Cosine of 5 pi over 6 minus 7 pi over 6. That would have been the same thing as cosine of negative 2 pi over 6. Or negative pi over 3. And negative pi over 3 is the same thing as pi over 3, or 5 pi over 3, which is 1/2. So you could have done it that way as well. All right, friends, why don't you guys go ahead and try this tangent one and see what you guys come up with. All right, go for it. All right, let's see what we got here. Here's u. I know that u is somewhere between pi and 2 pi. Okay. So it's between pi and 2 pi. So that means I'm not using anything up here. So for tangent equal to 1, that's going to be down here. So that's 5 pi over 4. So that means I'm dealing with a u value that is 5 pi over 4. In our other one, for v, it's pi over 2 to 3 pi over 2. So here we go. Pi over 2 to 3 pi over 2. So that means I'm not using these quadrants over here. And I'm looking for a negative tangent of negative root 3 over 3. So that'd be right here. And friends, that would be 5 pi over 6. So that's v. Well, 5 pi over 4 and 5 pi over 6, those don't have a common denominator, so I'm going to have to do this a long way, whether I want to or not. So tangent of u plus v. So that's going to be the same thing as tan, 1, tan. So tangent of u. Now let's change that. Tangent of 5 pi over 4. Minus plus 5 pi over 6. So we're going to do our tan formulas, our sum formulas, with those ones. So tangent of 5 pi over 4 plus tangent of 5 pi over 6 all over 1 minus tangent of 5 pi over 4. And tangent of 5 pi over 6. So we evaluate these. I end up with 1 minus root 3 over 3. This isn't going to be the most fun thing to simplify in the world. So 1 minus 1 times root 3 over 3. So if I multiply the top and bottom, everything by 3, to get rid of those denominators, I would end up with 3 minus root 3 all over 1 minus, oh, that was supposed to be a negative there. So that makes that a plus. 1 plus root 3. 3 root 3. All right, so that's a good answer, but we can clean it up a little bit because if it's on the multiple choice, we're going to want to clean that up just a tad here because we probably won't have any denominators left. So we end up with 9 minus 2 root 3 plus 3 all over 9 minus 3. So 12 minus 2 root 3 all over oops, I should have been a 6 root 3 in front of that. Sorry about that. There we go. All over 6. So we end up with 12 over 6 minus 6 root 3 over 6, which is going to end up being 2 minus root 3. So multiple choice, it will clean up just a little bit. So we just got to pay attention to it. Otherwise, you can leave it alone once you get rid of your, once you get your common denominator. All right. Let's try a little bit more here. We're just about done here for the day. I know it's a little bit longer of a day, but that's all right. What about if I deal with arcs? Now let's remember what arcs are. So arc is really nothing more than an angle. So what this is really asking me is tangent of theta, or what it's telling me is that tangent of theta is 5x minus 7. And what it's telling me here is that sine is the same thing. Sine is the same thing as 8 over x plus 2. So when I substitute my theta in for arc tan, that shouldn't have been theta, I should use alpha. There we go. Let's use alpha for that. When I substitute my theta, my alpha in, I get cosine of theta, which is arctan, minus alpha, which is the arcsine. So it's still just a sum and difference. It's just I have to deal with my acrtrig to begin with. And remember, for these ones, we always put it in the numerator. So we're always going to put our acrtrig in the numerator. So tangent of theta is going to be 5x over 7. So opposite, adjacent. And friends, if I do my Pythagorean theorem, I'm going to have 5x squared plus 7 squared, which is going to be the same thing as 25x squared plus 49. The arcsine, that would be over here. So here's my alpha. So that's opposite over hypotenuse. And again, we do our Pythagorean theorem again here. We can figure out what this side is down here. So x plus 2. Not going to bother multiplying that one out. I'll leave that one alone. Minus 8 squared. Or x plus 2 squared minus 64. So here we go. So what we're dealing with here is cosine of theta minus alpha. So we have cosine, cosine, sine, sine. Sine, cosine, cosine, sine, cosine, cosine, sine, sine, tan, tan, 1, tan, tan. Switch the signs and do it again. And since this was a minus, we're going to put a plus in between them. So cosine of theta, that'd be 7 over an ugly denominator. Times cosine of alpha. So x plus 2 squared. All over x plus 2. Plus sine of theta. So sine of theta, that was 5x over that ugly denominator. Now notice, these aren't pretty answers at all, but we're just combining things that we've done before. We've just got, as long as we take our time and we're just kind of careful about it, we'll be okay. And then what's the other one? Times sine of alpha. And sine of alpha would have been 8 over x plus 2. So we're going to go ahead and write this over a common denominator. We can go ahead and let's be our final answer. So 7 times the square root of x plus 2 squared plus 40x all over x plus 2 times the square root of 25x squared plus 49. All right, friends, why don't you guys try the next one yourselves there, and then we will talk a little bit about it. All right, let's see how you did. So we have the secant of theta is equal to 4 plus x over 9. And then we have cosine or tangent of alpha, which is 5 over x minus 11. So what we're really looking at here is sine of some angle theta minus some angle alpha. So it's just, again, it's a sum and difference, but it's going to be sine. All right, so let's think about secant for a second. So here's my angle. So here's theta. Secant is hypotenuse, so 4 plus x over adjacent, so that's 9. So that means my y value is going to be the square root of 4 plus x squared minus 9 squared, or 4 plus x squared minus 81. All right, then we add our next one here. Tangent is 5 over x minus 11. So that means this one right here then is going to be 5 squared plus x minus 11 squared, which is the same thing as 25 plus x minus 11 squared. All right, so let's go ahead and do our sine formula for that one. So sine of theta minus alpha equals, sine is the square root of 4 plus x squared. We get some ugly answers with this, don't we? Minus 81 all over 4 plus x. We don't actually ever use sum and difference formulas in calculus except for proving one formula. At least in calculate V. You'll use it in other stuff, just not in calculate V. So sine of theta, sine cosine, then cosine of alpha. So that'll be, cosine of alpha is 5, x minus 11 all over the square root of 25 plus x minus 11 squared. Sine, cosine, and then we're going to have cosine, sine. And again, just so we're aware here, this sine of theta, cosine alpha, minus cosine theta, sine alpha. That's just as a little reminder, this is what we're doing. So minus cosine theta, so 9 over 4 plus x, times sine of alpha. So x minus 11, I lied, 5 times the square root, or over the square root of 25 plus x minus 11 squared. So when we put it all together, we get x minus 11 4 plus x squared minus 81 minus 45 all over 4 plus x times 25 plus x minus 11 squared. All right, so these, so we can still use our sum and difference formulas. We can combine them with our acrtrig to create just more application with sum and difference. All right, so our final thing. What if I ask you to verify an identity? So you got to prove the uglier side. And I'll be honest, friends, that I see those sum and differences on that left side. In my mind, that is the uglier side. So here's what I'm going to have you guys do. I want you to go ahead and pause the video, and I want you guys to see, using your sum and difference formulas, can you verify this identity? All right, go for it. All right, we'll see how you guys did here. So if I see that cosine x minus y, I'd start off and I'd say, all right, using my sum and difference, that'd be sine, cosine, cosine, sine, cosine, cosine, sine, sine. I'm doing my cosine formulas. And since it's a minus, I'm going to put a plus in between. Cosine always gets the opposite sign. So sine, cosine, cosine, sine. Now I'm going to use my sine formula here. So sine, cosine, and then cosine, sine. And what we have here, we have sine, cosine, whoopsies, cosine x, sine y. And since that's a plus, on the sum for sine, we're going to use a plus there. All right, so we get it out of our sum and difference formula. So now we can actually go ahead and try to play with this a little bit here. And let's see here, we have 1 plus that right there. So what I look at, friends, here when I see this whole thing, I look again, I look for those context clues. Well, I see a 1 right here. So somehow I need to turn this into 1. And the easiest way I know how to turn it into 1 is just divide it by itself. So I'm going to take the sine x cosine y and I'm going to divide it by itself. Therefore, I have to divide every term by it. So cosine x times cosine y, and I'm going to divide, plus sine x times sine y. And I'm going to divide sine x times cosine y plus cosine x times sine y. One plus cotangent x tangent y. So I'm going to divide everything by sine x cosine y. So I can create that y, that 1 in my denominator. And by doing that, I'm hoping I actually get rid of some things along the way. So sine x times cosine y, sine x times cosine y, sine x, and cosine y. So we're canceling out everything that is common. So cosine y's will go away. The sine x's will go away. These all go away. And whatever's left, and that's where we're going to line up. So I have cosine x, sine x, plus sine y cosine y, all over 1 plus cosine x sine x. I'm going to go ahead and split these two fractions up here. I got one with my x's and I got one with my y's, sine y cosine y. And I can kind of see how this whole thing is kind of coming together, playing together here. All right, and now we have our final thing. We have just a little bit of our trig substitutions here. So let's see if we can't do some of that here real quick. So cosine x sine x, that would end up being cotangent of x. Sine y cosine y, well, that would be tangent of y. And then we have cosine x sine x, that's going to be cotangent x. And sine y cosine y, that would be tangent of y. And friends, it looks like we have now completed the proof. All right, so a little bit longer of a day. We had a lot more stuff and applications to kind of cover here a little bit. But good news, we got through it all. And we'll talk more about it in class tomorrow. We got one more video left in this chapter. So anyways, friends, have a great rest of the afternoon, and I will see you guys tomorrow morning. Take care.